So for instance, if we had the number 2.5 and we're multiplying by 1.5, remember before I told you that when we were dealing with mixed numbers and multiplication, to convert one of the mixed numbers, or the mixed number, into an improper fraction. So here we're going to do it for both of them. So for this one, 2 times 2 is 4, plus 1 is 5, and I write it over 2 because the bottom number is 2. And then in this guy, 2 times 1 is 2, plus 1 is 3, and I write it over 2 because of this guy. Now, we don't care about common denominators. In fact, we have the same denominator in this case, but we don't really care because for fractions, we multiply the top, 5 times 3 is 15, and we multiply the bottoms, 2 times 2 is 4. So the answer is 15/4, but we always check and see, can we simplify this? And in the process of seeing if we can simplify it, we look and notice that this is an improper fraction. So we're going to convert back to a mixed number. How many times will 4 go into 15? 4 times 3 is 12, and 4 times 4 is 16. That's too big. So 4 times 3 is 12. It'll go 3 whole times. The difference between 12 and 15 is 3, so that's the remainder. And we always write it over what's on the bottom. So the answer is 3 3/4. All right, so just keep in mind that whenever you're doing these problems, when you're multiplying a mixed number times another mixed number, all you do is convert them both to improper, multiply them, and simplify. And so we're doing the same process for these problems over and over again, but we'll just get some practice doing it as we go along. What if we have 1 1/3 times 2 3/4? How would we handle that? Well, 3 times 1 is 3, plus 1 is 4/3. And we're multiplying by 4 times 2 is 8, plus 3 is 11. And that'll be 11 over 4 because we always write it over what's on the bottom. And so whenever we get them into fractional form like this, we just simply multiply the top together. 4 times 11 is 44. And we multiply the bottoms together. 3 times 4 is 12. And so that ultimately really is the final answer, but we notice a couple things. We know that these are both even numbers, so we could divide the top by 2 and the bottom by 2. But we also notice that this is an improper fraction. So we have a couple of different ways we can go about doing this here, and it's really up to you how you choose to do it. But let's go down one road here. Let's say we divide the top by 2 and the bottom by 2. What would that give us? 44 divided by 2 is 22. 12 divided by 2 is 6. So we're presented with this fraction. But we notice again that this is still an even number and an even number. So we can again divide the top by 2 and again the bottom by 2. 22 divided by 2 is 11. 6 divided by 2 is 3. So we fully simplified this guy, but we had noticed also that it's improper. So let's take a minute to convert it back to a mixed number. How many times will 3 go into 11? We can only go 3 times. 3 times 3 is 9. 3 times 4 is 12. That's too many times. So it can only go 3 times, which gives me 9. The difference between 9 and 11 is 2, and we write it over the denominator here. So 3 2/3. That's the final answer. The truth is, at this point here, we could have converted to mixed number, but the mixed number that we would have gotten from this point, we would have to simplify the fractional part into lowest terms. So here we just chose to simplify here by dividing by 2 and then convert to mixed. But you really have some freedom in how you choose to do it. Now what if we have 1 3/5 times 2 1/4, and we would like to multiply these together? Well, the first thing we do is we convert. 1 times 5 is 5, plus 3 is 8, and we write that over 5. This one's 2 times 4 is 8, plus 1 is 9, over 4. So these are the two fractions in terms of their improper fractions. And then we simply multiply top, multiply bottom. 9 times 8, or 8 times 9, is 72. And 5 times 4 is 20. All right? So again, we try to simplify this. We notice that this is an even number, and this is also an even number, so we could divide the top and the bottom by 2. That's kind of what we did up here. We simplified by dividing by 2, divided by 2, and then we converted to mixed numbers. So you could do the same thing here. We could divide top by 2 and bottom by 2. But just to show you something a little different, I'll show you that you have a little freedom. Let's not divide top and bottom by 2 right now. Let's just convert this directly to a mixed number. So if we were going to convert this guy directly to a fixed number, what would we have? Well, how many times can 20 go into 72? 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80. That's too many times. So it can only go 3 times. 20, 40, 60. So that's 3 times. The difference between 60 and 72 is actually 12, and we write it over the bottom number, which is 20. So this is the mixed number form of it, 3 and 12 twentieths. But then you notice right away that this actually can be simplified, right? Because this is an even number, this is an even number. We could divide the top and bottom by 2, but I also know that I can divide the top and the bottom by 4. So when I do that, I will have 3, that stays the same. 12 divided by 4 is 3. 20 divided by 4 is 5. So you get 3 and 3/5, and that's the final answer. So we can convert to mixed and then simplify, or like we did here, we can simplify and then convert to mixed. You're going to get the correct answer no matter which way you choose to do it. And that's kind of the nice thing about math. As long as you're doing the right thing and you know the rules, you'll always get to the correct answer. All right? Now, let's do one that has slightly bigger numbers. What if we have 5 and 1/5, and I'm multiplying by 4 and 1/10? Now, these don't look like particularly big numbers, but watch what happens when we convert from mixed into proper. 5 times 5 is 25, plus 1 is 26, over the 5 from here. And this guy, 10 times 4 is 40, plus 1 gives me 41 over 10. So these fractions look a little bit more complicated because now I need to multiply the tops and multiply the bottoms. Sometimes in the course of working fractions problems, you're going to end up having to multiply big numbers together. Okay, and if you get to the point where you can't do it in your head from your multiplication tables, then you need to go off to the side and do that multiplication so that you can continue solving the problem. So in this case, we need to multiply 26 times 41. So I'm going to kind of go off to the side and say 26 times 41. I'm going to multiply these together. 1 times 6 gives me 6. 1 times 2 gives me 2. Then I go to the next line and I add my 0. 4 times 6 gives me 24, so I'll put the 4 there and carry the 2. 2 times 4 is 8, and then 8 plus 2 is 10, so I'll put a 10 here. And then I start adding up. 6 plus 0 is 6. This gives me 6, this gives me 0, this gives me 1. So the answer is 1066. So when I multiply 26 times 41, I know it looks crazy, but you get 1066 on the top. Now on the bottom, this is something I can do myself. 5 times 10 is 50. So I get 1066 over 50. Now there's several different things you can do at this point. You need to simplify this fraction. There's a couple things you can do. You notice that they're both even. You get a 6 and a 0, so you know they're both even. You could divide top and bottom by 2, and you may have to do it again and again and again. That's totally fine. But you also notice that this is way improper. Bigger number on top than what you have on the bottom. So you have freedom here. Let's choose to convert it back to a mixed number right now and see what we get. So my question to you is, to do this, how many times will 50 go into 1066? How many times will that happen? Well, basically you need to divide here, right? So again, you're going to have to get your separate little sheet of paper, your separate part of your paper, and you're going to have to take 1066 and divide by 50. All right, divide by 50. So you try to see if 50 will go into 10, and it won't. So then you look at the third digit and say, will 50 go into 106? And it will. It will go 2 times, because 2 times 50 is 100. So 2 times 50 is 100, and we subtract these. 106 minus 100 gives us 6. Then we take this 6 and drop them down here, and we say, how many times will 50 go into 66? It will only go 1 time. So we multiply times 50, getting this, and we subtract. 66 minus this guy gives me 16. And I see, can 50 go into 16? And it actually can't. So what you end up having, since you can't divide anymore, and since we've used all of our digits, the answer that we get is 21 with a remainder of 16 left over. So when we take 1066 and we divide by 50, the answer we get is it can go 21 whole times with a remainder of 16. That's what it means. So when we're converting from this to a mixed number, how many times will 50 go into 1066? Well, we said it goes 21 times, and 16 is the remainder left over. So the 16 goes up here, and we put it over the 50. So you see, sometimes, even though the numbers are big, it's not a big deal, but you do have to go off to the side and do some multiplication and some division. So we look at this, the answer we get is 21 and 16/50ths. which looks to be awesome. But then we realize this is even and this is even. So let's divide this by 2. We'll divide the bottom by 2. So the answer we get is 21. 16 divided by 2 is 8. 50 divided by 2 is 25. And I can't simplify this anymore. That's the final answer. So when you have 5 and 1/5, and you multiply it by 4 and 1/10, you get 21 and 8/25. Now you always should do a sanity check to make sure that you're at least in the ballpark. What we're saying is 5 and 1/5 is a little bit more than 5 of something. 4 and 1/10 is a little bit more than 4 of something. So you can think of 5 pizzas plus a little bit more here, and this is 4 pizzas plus a little bit more. You know already that 5 times 4 is 20. Right? So it makes sense that since this is a little bit bigger than 5 and this is a little bit bigger than 4, when I multiply them together, I should get something a little bit bigger than 20. And the answer I get is 21 and 8/25. So the answer is in the right ballpark. So you always want to make sure of that when you do any kind of calculation. All right? So let's go off and do a couple of additional problems. Here we have 2 2/3 times 4 4/9, and we're going to multiply these together. And just like we've done for all of these, we're going to change them to improper fractions. 3 times 2 is 6, plus 2 is 8, and we'll put it over 3, and we'll multiply. 9 times 4 is 36, plus 4 is going to give me 40, and that's going to be over 9. So I have 8/3 times 40 over 9, and I'm basically going to try to see how to calculate this, and so I multiply tops, multiply bottoms. All right. Now for this, it's a little bit easier because I'm trying to multiply 8 times 40, right? 8 times 40 is 320, and I know that because I can cover up the 0 here, and I know that 8 times 4 is 32. And since there's an extra 0, I just tagged the extra 0 here. But if I didn't know that, if I just didn't know that little trick, then I would say 40 times 8, and I'd multiply. 8 times 0 is 8. 8 times 4 is 32. There's nothing else to do, so the answer is 320. Now on the bottom, 9 times 3 is 27, so that goes on the bottom. So you need to, at this point, say this is the answer. Let's convert it back into a mixed number. So you need to see how many times will 27 go into 320. How many times will that happen? So you look, 27 surely will not go into 3, so let's go to the next digit. 27 goes into 32. How many times? Well, only one time, because 27 is pretty close to 32. All right, and so once we have that in place, we multiply this and we get 27, and we subtract. And the difference between 32 and 27 is going to be 5. So we'll just put a 5 down here below, and then we drop the 0 down. We'll have 50. All right? And then we see how many times will 27 go into 50. Well, again, it can only go one time because if you know that 25 times 2 is 50, so since this is 27, it surely can't go more than one time. So we multiply, and we get 27 here, and we subtract. All right. Now for this one, you may need to borrow a little bit, so we can make this a 10. We can scratch this out and make a 4. So 10 minus 7 will give us 3, and 4 minus 2 will give me 2. So we get a difference of 23. So then we see, can 27 go into 23? And it can't. And there's no more digits to drop down, so we're basically done. The answer is 11 with the remainder of 23. How many times can 27 go into 320? We just figured out that it's 11 whole times. What's the remainder left over? 23 is what's left over, and we write it over the fraction of 27. And we know that we can't simplify this anymore because 23 and 27 are already pretty simplified, and we can't do anything more with it. So again, sometimes you're going to have to multiply large numbers. Sometimes you may have to divide large numbers. So make sure your division and multiplication skills are at a good place when you're multiplying mixed numbers, because sometimes you just have to do it. Now let's say we have 3 1/5 times 5 2/3. All right, so let's do the same old thing. This will be our last problem. 3 times 5 is 15, plus 1 is 16, and I'll write it over 5. And here, 3 times 5 is 15, plus 2 is 17, and I'll write this over 3. All right, so it's sort of the same thing. I get 16 over 5 times 17 over 3. And I need to multiply the tops and the bottoms. All right, I don't know what 17 times 16 is off the top of my head, so I have to go over here and figure it out for myself. So 7 times 6 is 42, so I write the 2 here and I carry the 4 up there. 7 times 1 is 7, plus 4 is 11. So I'm going to go ahead and do that, okay? And then when I drop to the next line, I have to put a 0 here. Now I'm going to erase this 4 that I used because now I'm multiplying by 1. 1 times 6 is 6, 1 times 1 is 1. And now I add these together. This will be a 2, this will be a 7, this will be a 2. So the answer is 272. So whenever I go over here, 16 times 17 is 272, and the bottom 5 times 3 gives me 15. So that's the answer in terms of an improper fraction, but we always want to convert. So we always want to see how many times will 15 go into 272. So let me change colors down here and go down. I can't figure that out off the top of my head, so I'll say 272 divided by 15. How many times will 15 go into 2? We can't really do that, so let's go to the next digit. 15 goes into here. It can only go one time because 15 times 2 is 30. That's too big. So let's go with 1. 1 times 15 gives me this. Subtract. 7 minus 5 gives me 2. 2 minus 1 gives me 1, so I have 12. And then when I do the subtraction, I always have to bring this down here. So I'm going to have 122. So now what you have to figure out is how many times will 15 go into the number 122? And there's a little bit of trial and error involved in that sometimes, okay? But let's just say 15 times 8. Let's see what that's equal to. 8 times 5 is 40, and 1 times 8 is 8, plus 4 is 120. So we know that 8 times 15 is 120, and that's awfully close. So this is going to be 15 divided by 122 is going to be 8. We multiply these. We already know it's 120. Now we subtract. 122 minus 120, of course, gives us 2. There's no other digits to drop down, and we've done all the division we can, so it goes 18 whole times with a remainder of 2. All right, so now that we have that squared away, how many times will 15 go into 272? It'll go 18 whole times with a remainder of 2 over 15. 2 over 15. And there's really nothing else that I can do to simplify this answer anymore. The 2 and the 15 are already fully simplified, so the answer is 18 and 2/15. So I want you to understand that whenever you're multiplying by mixed numbers, you're doing the same thing that we've always been doing. You want to multiply those fractions. So to put them in the right form, you always convert them to improper fractions. Then you multiply the top, you multiply the bottom. All right, and then frequently at the end you'll need to convert back into a mixed number. Now sometimes, depending on what your problem is, you're going to end up with some large multiplications. You do that off to the side sometimes. And also if you convert back to mixed numbers, sometimes you may have to divide in order to figure out how many times it can go in and what the remainder is. Now when the fractions are really small, like in the beginning of this lesson, you know, like over here. It was pretty easy for us to convert this back to a mixed number because we know how to divide this. We know what the remainder is in our head from multiplication tables. But when we have larger numbers, you have to go off to the side and do that division, you know, separately. And so you need to be good at division and multiplication in order to deal with mixed numbers a lot of times. So make sure you understand this, solve all of these problems yourself, and when you're comfortable with it, go off and do the worksheet problems, and then follow me on to the next lesson where we'll be doing some word problems where we're multiplying mixed numbers.